See this problem. If a length of a wire conductor is doubled by stretching it while keeping the potential difference constant, by what factor will the drift speed of electrons change? Our motto is, there is a conductor. I am taking a microscopic view. There is a conductor. So in it an electron is moving with some drift velocity Vd1. The conductor length is L1 and cross-sectional area is A1, and its resistivity or specific resistance is rho. You are stretching the same wire such that its length is going to be increased, L2, with a cross-sectional A2. L2 is the second length, where that second length is equal to double of the first length, that means 2L1. So in that situation, what is the relation between the drift velocity with the first drift velocity, or we need to find out the factor of change in drift speed. That is our motto. Now I am moving to investigation. L2 is equal to 2L1, we already know this, and V, that is potential difference, is constant. Now I am going to resolve the things. We already know that I is equal to NEAV, where I is the current flowing in that conductor and N is the number of electrons passing in unit volume. So it is number of electrons in unit volume. So that means in that conductor, if you consider a unit volume, N is constant, and E is charge of electron, and A is the cross-sectional area of the conductor, and Vd is the drift speed of the charge inside that conductor. So these are the quantities having relation with the current. And now I am taking another formula, that is resistance. R is equal to rho into L by A. L is the length of the conductor and A is the area of cross section. Now, and we already know that V is equal to IR, where V is the potential difference across the resistor R, and I is the current passing through it. Now I am writing V is equal to INEAVD into R, rho into L by A. A gets cancelled, so the remaining things are V is equal to N constant, E constant, Vd we don't know, rho constant, and L is going to be vary. So in this expression, potential difference is constant, N constant, E constant, and rho also constant. So the varying things are drift speed and length of the conductor. That means if length of the conductor increases, there may be a change in the drift speed. So if I take a relation from this, Vd1 L1 is equal to Vd2 L2, because anyway from this relation I can write like Vd into L is equal to constant. So with this I am writing this expression, Vd1 L1 is equal to Vd2 L2. Now from the given things, Vd1 into L1 is equal to VD2 into what is L2? 2L1. So L1 gets cancelled. So VD2 is equal to half into VD1. So what is the factor of change? It is half. That means drift speed will be halved if length of the conductor is doubled.